So, just open up this thing here. And I'll share here as well. This. All right. So here.
So we done everything now, our assignments
Yeah.
and the... Okay.
Oh, I think you still need to do one more tutorial. So I'll probably release it this afternoon, but you'll have until not next week Monday, the Monday after, so the last day of term to do it.
Okay, I see, sir.
So, do this. As usual, we'll wait a bit to give people a chance.
Yeah.
This. Right, so I think for today we're going to try and do these things. Are you able to see my screen?
Yes, sir. Is sir putting this on YouTube also?
Yeah, it's also streaming on YouTube.
Okay, see, thank you.
Let me just have a look. Do this, and then if I... Yeah, okay, excellent. Right, so this is what we're going to look at today. Here we will go. Right. We'll give it another 2 minutes. If there are any questions about the assignment or the course or anything, go right ahead and we'll try to answer them. I think for that we might as well add another page. This as all right. If there are no questions before we begin, we might as well get started. So we can go over here, talk about Java basics. So, for those of you just joining us, this is the series of revision work we're going to do for your test. Your test is going to start in 1 week. The test will be opened. Let's actually put here test format. So the test will be on eCanva. And I'll post an announcement after this lecture as well. It'll be available from 12 noon on the 20th of October. So October until 12 noon on the 21st. So this is Thursday and this is Friday. Once you start, you will have 3 hours to finish the test, and it will be a 50-50 split. So half of it will be theory, right? So this is multiple choice, and fill in the blank, so on, and then half will be prac. So we will ask you to code and submit pieces of code. You won't have to submit files. We'll make it so that you can just submit your code in the, like copy paste your code into forms. So this is the test format over here. It'll be on eCanva. It'll be available for 24 hours, right? So from 12 until 12. And you will have only one attempt or one submission.
Is there saying we just submitting just one .java?
No, so it'll all be under the tests and quizzes, and the question. So let's do a little.
So you're saying, so instead of me submitting a .java source code, I'm just copying my code and putting it on the thing.
Yes. So the question will be like this, and it'll say complete the class, something like this, right? And we'll give you a bunch of details.
Okay, I see.
And then there'll be like your answer, and it'll be like a little text block.
Yeah.
And you can just copy paste your class in there.
I hope there won't be any issues, because last time I remember in first semester, sometimes the Canva wouldn't register our indentation, but I don't think that will be such a big thing.
Yeah, it shouldn't be a problem. I'll maybe put I think if you want, you can say like show the rich markup or whatever. There's usually like a link or something, and I'll change your text box to work, but it shouldn't be an issue.
It should be fine then. Yeah.
All right, so it is 8 minutes past. Let me just do this, and then do this over here. So test format. I don't know why it's so small. Do that. Okay. So let me just double check that we don't have any questions before we start. So someone asked what my master's degree is on. It's deep reinforcement learning, so it's a subsection of machine learning and part of AI in general. But I can discuss it more tomorrow. Today we're going to focus on some revision. So let's talk about the Java basics. First of all, something you should know is that, or hopefully know, is that Java is a compiled language. A compiled language, and it is also a strongly typed language. Strongly typed. Okay. So, what does compiled mean? Compiled means that we have some form of Java source code. So we have a .java file, right, like this. And that Java file has our code. So that looks something like, the human readable code, public class hello, right, something like that. Then we take the source file and we hand it to something called a compiler. So in this case, it's the Java compiler. And then that produces our .class files, right? So we have a .class file. And this .class file contains something called Java bytecode. So if we have a looky-loo in here, right, it has Java bytecode. And then this Java bytecode in the class file is put into the JVM, and the JVM interprets the Java bytecode and works directly with the system. So you have your like hardware layer and your hard drive and everything, then the JVM sits and communicates with the system. So what this means is that whenever we need to run our code, our Java code on a different system, right? We only need to make sure that the JVM can run on that system, because the JVM just interprets the Java bytecode. That means that Java, the benefit of Java's method of compiling, so this turning the source file into the class file, this is the compile process. The compile process, and when you load the class file to run it, this is run, right? Compile and then run. It's like the little division. So you compile and then you run. So what this means is that Java has a unique feature, or at least the advantage of being compile once, run everywhere. Okay. This everywhere comes with a little asterisk because that everywhere requires the JVM. Okay. So with this, let me see if I can duplicate this page. Not sure I can copy this page. That's fine. We'll just try to do this, duplicate over here. So in this compile process, the JVM is what we are targeting. So we only need to compile once. Once we have our class file with all the bytecode, then we can run it on any system that has the JVM installed. This makes it very nice and useful for Java, because you can run it on a whole bunch of systems, as long as you have the JVM installed. All right. Any questions about that? Okay.
Nothing much, sir.
All right. So how does this differ from something like Python? Just give me a second here. So Python, over here, Python is an interpreted dynamically typed and kind of weakly dynamically typed language. So what this means is you write your Python code in a .py file like this, and then you load it into the Python interpreter. I think it's CPython is the standard Python interpreter. This program and then this program works directly with the system, so it makes the appropriate operating system calls. Now, what is nice about Python is that you can script with it. You have your read, evaluate, print loop, right? Your REPL, the Python REPL, I think they call it idle, right? So the Python program that you can run. This is very nice because you can kind of just script things without having to compile. In Java, whenever we change our Java file, whenever this is changed, we need to then recompile before we can run it to see the changes. With Python, the Python file is just interpreted at runtime. However, one of the benefits of compiling is that we can optimize our code during the compile step. Another benefit of compiling is that we only need to compile once and we can do a whole bunch of checks, right? So we can check if there are potential issues or whatever. With Python, it has to start parsing all of the file first from top to bottom, and only then will it run into errors that it's interpreting. Okay. So with compiling, we get a little bit of safety and pre-processing done. All right. So now let's talk about, no, that's fine. Let's talk about, I'm trying to find how I can just select everything. Select region, do this, right here, delete it. And now let's talk about the typing system in Java, because that's the next important aspect. In Python, we never had to say what the type is of something, but in Java, every variable and every attribute needs to have a type. So now we're going to look at what it means for something to be a type. In Java, there are a couple of types. There are numbers, so integers, floats, doubles, and longs, right? Something like this. There are strings and chars, and then there are kind of the Boolean things, so Boolean, right? So in Java, we have all of these, and minus the string type, these are all what we call primitive types. Primitive types, right? And
Listen,
so
one thing that
yeah,
really like the primitive and reference types. Like I just read it, but I read it without understanding. Like I don't understand like the
say
difference
again,
between
the difference between
the primitive and reference. Like I don't understand.
Yeah.
What does it do? Understanding when I code.
Yeah. So so for primitive types, these are very well understood. So every primitive type has a size associated with it. So if we put the type over here, type, and the size. So an integer on a particular computer thing, but the JVM standardizes it. I believe integers are 32 bits by default, or they might be 64. I'll have to double check. 64 bits, right? So if you look in terms of the computer memory, whenever you say something like int x, right, like that, then Java goes to the computer memory block and says, okay, there are 64 bits over here, and I want you to block off those 64 bits, and that's where x is. However, with the reference types, it's not as easy to know what the exact size is at compile time or at runtime, right? So we'll quickly look at this, which is to say a string. What is the size of a string? So with integers, we have a size, and then we have a min value and a max value, right? So with integers, we know what this is, and we know what this is. Let's do that, and we know what this is. But for something like a string, and note that it's in a capital S, for something like a string, the size is unknown. Because you could either have like a single character as a string, or you can have 3 characters as a string, or you can have like a whole book as a string, right? So the size is unknown. So we need some sort of special way to store strings. And so what we do is we go to the memory block. Let me just erase this. We go to the memory block and we say, okay, we're going to be storing quite a big string. So I need you to give me a whole block of memory. But this is stored somewhere. So this is at some address in the memory. If you imagine the RAM is like a giant chunk of memory. So we're saying this should all be allocated for a string. And then when we need to find this or access it, that is a reference. And that reference is an address, right? So A, B, C, 3, F, D, or whatever, right? So this reference, this memory address, depending on the computer architecture, is a certain size, but I think it's usually 32-bit hex. So now we have something that is a known size, and we can store that. So all references are a specific size, but if something doesn't have a determinate size at runtime or at compile time, then we create it in memory, and we just reference, we just point to that memory, which is the reference. Does that answer your question? So for...
It's like put in memory. It's like basically memory.
Yes. And the type, so in Java, the type specify how we lay out that memory and what it looks like. So with primitive types, there's a known size, and there's usually a known minimum and maximum value. However, with non-primitive or reference data types, they're usually objects, and they're usually written with an uppercase letter. Does that make sense?
Yes, sir. Yes, sir.
Okay.
I see now.
So let's just put this here. Java basics. So because we are a statically typed language, at compile time, we should be able to determine the type of a variable. So when we compile, there's a rule, compile rule. All types must be known. Okay, so if we declared a variable, let's call it x, and we said x is equal to 5, right? In Python, this is perfectly legitimate code. In Python, we just wouldn't have the semicolon. But Java, the compiler of Java, has an issue with this. We haven't declared what type x is. So this 5 could work as an int, could work as a long, could work as a double, and a float, right? So there's ambiguity for the compiler here. In Java, the rule is that if you're declaring a variable, then you must associate a type with that variable. So the syntax is like this. So variable declaration. Variable declaration says type, and identifier. The identifier is just a way of saying the name of the variable. Okay, so this here is variable declaration. When we then give it, then once we've declared it, we can say, okay, then the identifier is equal to some value that matches the type of the identifier. So these, we call them literals or values, right? So if you assign an identifier of a known type to a literal or a value, this here is referred to as variable. Let's not misspell that. Variable assignment. Okay. because we are assigning a value to the variable. Okay. Finally, if you combine these two and you declare the type, you give it the identifier, and you immediately set it equal to some initial value. This is called variable initialization. Okay, that's this over here. So in Java, we have to specify a type for all of our variables, or we have to be able to determine the type of a variable throughout. Is everyone okay with this? Let me double check if there are any questions. Okay, no questions so far. So we all know how to declare, assign, and initialize variables, which is great. So Java basics, variables, and casting. Okay. So in Java, we have kind of a hierarchy of variable sizes with things like ints over here and doubles on the bottom. And that's just for how much information we can store, right? So an int can only store, negative the maximum integer to positive the max integer, I think -1, or this is the max integer -1, right? So we can only store integers. With a double, we can store like real numbers. So we have a number of leading significant digits and then a number of decimal places we can also store. So you can see how the information increases with the type that we're using, right? And of course, a Boolean type. Boolean types only contain a single bit, 1 or 0. So a single bit of information. With Java, if we have a type, so let's call this type A, our variable x is equal to, and we have type B, right, of some value. So we give it a value, right? If there's a mismatch in these types, the compiler will complain at you, okay? Because Java is saying, well, we expect type A over here. So if we have an integer, x is equal to 5.3, which is set as a floating point, right? The compiler is going to complain because it sees type on this side is int, and that is not equal to a float, right? So there's a potential for us to lose information if we try to put 5.3 into an integer, because we could lose this 0.3, this decimal data. So in Java, to come around this, to tell the compiler that we're okay, we know we're potentially losing information, we do something called type casting. And typecasting is the way for us to change deliberately from one type to another. Okay, so when we cast, we're telling Java, look, you can convert from this type to this type. We're aware that the data might not transfer completely, and that's fine. And the syntax for that is we have some sort of type, and the type we want to, so the type, let's change this. So we use parentheses and we say the type to cast, and then our value. Or we can have an expression or we can have a literal. All right. Is everyone okay with that? So if we were to fix this over here, we would now write it as int x is equal to int 5.3f. And you're telling Java, I'm aware that if I do this cast into an integer, I will be losing the 0.3 aspect of the floating point number. Is everyone with me? Do you understand what I mean about typecasting? Okay. So that's variables and so on done. So let's have a look quickly at our roadmap. We've looked at compiling, basics, and bytecode. We've looked at variables, types, and assignment. So these are out. Okay. One small note before we move on, because we'll do it as well, is Java, right, types, and then we have arrays. Okay, we'll look at arrays on Monday when we do, so we'll do arrays and loops. But for an array, the declaration looks as follows. The declaration looks as follows. It's type and then square brackets, right? So arrays work a little bit differently to things like array lists. When we create an array, we say new, we give it the type. We say new, we give it the type, sorry, and then the length of the array. So type, and then the number of elements, right? And the reason why we call these primitive arrays, primitive, so this is an example of a primitive array, is because it is just that. It determines what the possible size is of the type at runtime, and then creates a number of references to space and memory for that type. So if we have something like an int with 3, so an array with 3 integers, the block of memory will end up looking like this, and I'll go 1, 2, 3, and I'll say, okay, this over here is the address. So there's an address over here, a reference, and this will be int 0, this will be int 1, and this will be int 2, right? And because an int has a known size of how many bits it is, it's really efficient to pack the variables together like this. And primitive arrays have very limited methods associated to them. They have an attribute for length, right? So length just gives us whatever n was when we used to create it. And then it has a syntax where we have our array, and we can access something like this. And we can put, like our whichever index we want. However, it doesn't stop us from trying to access past the array, right? So if we give a number here, say an index that is like 5, right? It'll go, okay, cool, I'm going to go from this memory address, I'm going to go 0, 1, 2, 3, 4, 5 over here. And in here, we have just garbage memory. Okay, so we don't get any safety rails when we're using primitive arrays, but they're really compact in memory. All right, so that's just kind of an aside quick on the types before we move on to input and output. So let's talk about input and output. Are there any questions? Am I going too fast? Is the pace okay for you guys? Yeah. Is everyone with me so far? Okay. So the most common way for us to do input and output, and especially output, is to use system dot out. Okay, system dot out has a bunch of useful methods associated with it. It's got print line, which asks for some string, right, or something that looks like a string. It asks for print, which is the same as print line, but it doesn't add a new line character. So there is a whole bunch of methods. I believe system.out.format is also very useful. Format over here, which takes, a format string and then a list of arguments. Okay. So for output, we mostly use system.out. But for taking input, we use the scanner, right? And when we create a scanner, we have to declare a scanner object, typically like this: scan new scanner, like this, and we give it system.in. Okay. Can someone answer for me why we have a new keyword in here? Anyone want to take a guess? Okay, so we have a new keyword because we are creating an object of type of the scanner class. And if you'll recall, in Java, a class is the same as a type. In the same way, an interface is also a type. Okay. In the same way, an enum is also a type. Okay. So in Java, these are all types, and then primitives are also types. Okay. So when we do the scanner, we first have to create it. So that's step one. And then we need to start reading or asking for user input. So scanner has also a whole bunch of methods that you can use depending on things. So this is step one. Step two, we say, okay, we have scan dot next, and then what? Next line. We'll try to read an entire line of input until it hits a new line character and return a string. We also have scan dot next int, which returns an integer. Next, right? So there's a whole bunch of stuff. Next will return a string based on the separator. So the separator by default is a space. So it'll break the line up into different things with a space and return it like that. And then finally, we have something like scan.hasNext. And scan.hasNext is useful. HasNext like this. Scan.hasNext is useful for checking, like, is there still a line to read from something like a file, right? So when we have a file, is there still a line to read? Is there still like something like an item in the string that we're reading through? So it just means we haven't reached the end of file. So typically this is written like this: end of file or end of whatever the string we're reading from. Okay. And finally, when we're done with the scanner, we want to say scan.close. Okay. especially if we've been using a file, because we want to make sure we close the file once we're done reading from it. Right. So with all of this, when we are working with user input, with all of this, there is the potential for exceptions. Okay, so this is a big warning sign. Exceptions can occur. There is the input mismatch, input mismatch exception, arithmetic, like a whole bunch of different exceptions, IO exception, bunch of things, file not found, right? So there's a lot of exceptions, and the way we handle those is through a try-catch. And we'll talk about try-catch in the future revision sessions. Okay, so that is basic input and output. And I see we have 20 minutes left. That's good. Let's talk about conditionals, so ifs, switches, Boolean expressions. Okay, so over here, go back to our slide. This is typecasting, this is scanner, go down here. So we have Java basics, Java revision, and we're talking about conditionals. So right, so conditionals, otherwise known as branching control flow, or a control flow, as opposed to looping control flow, right? With branching control flow, we will start our program, we'll go through, and then we'll hit like a decision point, right? And they'll be like, yes, do this way, no, do this way, or maybe go this way, right? So we're branching out, but the whole time the program is running this way. And then we might reach like different actionable points, or we'll reach like another decision and keep going, right? Something like this. So this is all branching control flow. It runs from one end to the other. And we use things like if statements and switches. With looping control flow, we'll start here, we'll start moving, then we will hit something like a loop, which has some condition, and the loop will do a series of steps, and then go back up and check the condition, and finally, once the condition is complete, it'll run to the next section of the code, right? So this is looping control flow, and this over here is branching control flow. You can think of it as making decisions. Right, so Java conditionals. So with Java conditionals, and especially the most basic one, the if statement, we have if, and then in parentheses, we have some, what we call a Boolean expression. So the Boolean expression must evaluate to true or false, right? Then we have our open parentheses, then we have the closed parentheses, and we have the body. The body of the if statement, so this is if true. Let me just do this. So in this body, this gets executed if the expression is true. Okay, so if we don't have anything else after the if statement, this will only execute if it's true. But if we want to do something, in case the expression is false, we will put something like an else statement. Let's do this. Else, right? Open parentheses, close curly braces, and over here, this is if it's false. Right. However, if you want to check kind of multiple expressions, then we can go over here, and let's call this over here, we'll call it expression A. Right, so this is A. And this over here executes if A is true. All right? Then we can say else if expression B, open parentheses, we evaluate these statements, and in this case it says A is false, right? But B is true. Okay. And then finally, if we have another else statement here, else over here, this over here says that A is false and B is false. Ugh, it's horrible writing. Right. So that is if and else statements. Okay. You can see how the flow of the program is still just kind of branching. So over here, it'll branch off if A is true. And then over here, it'll branch off if A is false and B is true. And then over here, it'll execute something if A is false and B is false. Okay. Is everyone with me so far? We can also nest the conditionals. So we can nest if statements where we say if expression A, right? So let's do this. So this is executing if A is true. Then we can say, okay, if A is true, if then B. So this is still within the body of the first if statement. If B, right, then this over here says if A is true and B is true, we do the following, right? So we can nest them. However, what this nesting means is that A has to be true first. So we have to check that A is true before we can check whether or not B is true. Okay, so this statement can only, this expression can only ever be checked if A is true. All right. But sometimes we want to check multiple conditions at once. And how we do that is with, let me just duplicate, is with Boolean expressions. So over here, if we want to check both A and B are true at the same time, then we can do it together. So we use something called a Boolean expression, which is what A was anyways, right? So with a Boolean expression, it just has to evaluate to true or false. So we have things called, let me just write it, I'll write it here and then move it away. So a Boolean operator. A Boolean operator is something that returns true or false, right? So you can think of mathematical operators or arithmetic operators. Operators are things like plus, minus, divide, multiply, right? These all give us another number. The Boolean operators use things like or and not, right? Like these are the operators to give us things, to give us a true or false statement. So the Boolean operators in Java are either unary or binary, and that just means how many arguments or how many operands it needs. For unary, uni meaning one, we have the not operator. So not x gives us, if x is true, it gives us false. If x is false, it gives us true, right? Whereas binary says, okay, we need x and y, and then there's some operator in the middle. And that gives us a Boolean. True or false. Okay. And the Boolean operators we have in Java are AND, which, let me just make sure I can draw this correctly, are AND and OR, right? So this says if x and y are true, then give us true. Let me make some space here. Okay, so x, I'll just do it this way, and y, right? So if x is true, and y is true, then it returns true. If only one of them is true, so x or y, if only one of them is true, then it returns false. And if x is false and y is false, then it returns false, right? So that's the AND operator over there. And then the OR operator, x or y, tells us that if either of these are true, then return true. And if none of them, only if none of them are true, then you return false. Okay. So you can start combining these expressions. So we could now do, if we wanted to simultaneously check if both A and B are true, we would say if, open our brackets, if A and B, right, then this will execute, so do this. If A and B, then we have A is true and B is true. It will execute. Okay. So if we then change this to if A or B, then only one of these has to be true for this body to execute. And a final operator that yields a Boolean, and one you will use quite often, is the equal sign, the double equal sign. And this is a equivalence, what we call an equivalence operator. Okay. It returns, so x and y. Okay, and if these are equal, it will return true. Now, I see we're almost out of time for today, but before we head off for today, let's quickly talk about how the equivalence operator works and some of the pitfalls. Okay, so the equivalence operator over here is very basic. In fact, you would call it primitive. Okay, so it's very basic, it's very primitive. And when we talk about primitive, we think about like the primitive variables. And the reason why I say primitive is because the equivalence will directly compare values. But if something is like a string, where a variable that contains a string is actually just a memory address, so there's a string at 5563, right? So at a memory address, if we had two strings with different memory addresses, with string at 2111, if we had two different strings, even though they have the same value or contents, right? The equivalence operator only checks this. It checks the values, not the values, sorry. It only checks the references. And it will say that these two are not the same reference, and so the equivalence operator will give us false. Okay, and that false is very tricky. So some of you might get stuck or in the panic of the test, might forget this. So I'm trying to bring it up again. Instead, when we are comparing strings, we should say string dot equals. Okay. So it'll be x dot equals y. Okay. And this whole rule also works for arrays. So with the equals operator, if we have an array of int, or let's make it float, just to change it up. So a float array of like length 1, right? So we have x, new float 1. So it's just containing one float, and float array y is equal to new float 1. So we know that currently x is given some memory address for a float array, right, that contains a single floating digit, a single floating point digit, like this. We also know that y has an array with a memory address with a single floating point digit. Okay. However, if we use the equals operator on x and y, it will see that the memory locations are different and therefore give us false. Okay. So this is very basic, very primitive. And if we want to check if the content is the same, we need to figure out a different way to do that. And the way we can do that is with a loop, which we'll discuss tomorrow. Not tomorrow, Monday. Right. Or actually, we'll do it tomorrow. I'm going through this. I feel like we have quite a bit of ground to cover for all the revision. So tomorrow will be another revision lecture. All right. Any final questions before we cap off today's lecture?
I don't know, sir.
Okay. It's a lot of information, but what I want you to do is not try to make notes about everything or absorb everything. Instead, what I want you to do is be like, oh, I didn't know this, or I was unsure about this, and then go and review that work. Okay. All right.
Sure.
Okay, everyone. Enjoy the rest of your day, and I will see you tomorrow for revision 2. All right.
Yes, sir.
Have a good
Thank you.
afternoon. Have a good evening, and I'll see you tomorrow.
Thank you. Bye-bye.
Bye-bye.